The procedure. It describes what is done to the subjects with the materials. Analogous to a recipe or a blueprint, describing the steps taken to develop, administer, and evaluate the research study. It serves as a guide for replication, from sampling and selection of subjects to the final data analysis. The tasks and protocol. The sequence, the task performed by the subjects, the manipulation of the independent variable, and subsequent measures of change in the dependent variable. A step-by-step description of each of the components that together constitute the experiment. So a very clear sequence. A poor test environment can jeopardize any behavioral or instrumental measurement. For example, research data may be contaminated by distractions, noise, interruptions, poor lighting, inappropriate stimuli in a test environment. The degree to which test environment's effects may influence a measure varies depending on the measure. Test environment is very important. Internal validity. The test environment should be specified if measurements can vary from one environment to another. It also affects external validity. The environment may serve as a reactive arrangement. Generalizations may be limited to individuals functioning only in that particular environment. Remember, there's the balance between internal and external validity. Subject instructions must be clear and appropriate for the population being measured. For example, children versus adults. They should remain constant across subjects. Subject instructions are actually part of the instrumentation, the tools by which the researcher attempts to elicit the desired response or behavior. Inadequate, inappropriate, poorly worded instructions thus pose a threat to internal validity. The critical evaluator needs to ask two questions. Are the instructions appropriate to the task at hand? Is there sufficient detail provided to allow for replication or for clinical application? Observer bias. When humans are judges, there is opportunity for judgments to be confounded by observer bias. For example, judges' standards may change from one experimental session to another. Raters may be influenced by the knowledge of the purpose of the investigation. Observers may make judgments based partially on their expectations about the behavior of the subjects in different groups. For example, biases children with and children without hearing loss. A non-interactional effect occurs when the observer does not actually affect the subject's performance, but does affect the recording of the subject's behavior. Expectancies of the observer serve to bias his or her measurement of the subject's behavior. Observer biases, their observer effects, that is, systematic error in observations of behavior. Interpreter effects, systematic errors in the interpretation of behavior. Intentional effects, dishonesty or carelessness in recording the data. Interactional effects, when the observer's interactions with the subject actually change the subject's behavior during the experiment. 5 factors associated with human observers that may influence behavior of the research subjects. Biosocial attributes of the experiment. Psychosocial attributes of the experiment. Personality characteristics, anxiety, hostility, authoritatism. Situation and variables, experimenter experience in prior experiments or on earlier trials of the same experiment, familiarity with the subjects, modeling effects, the subjects may behave as the experimenter does, or self-fulfilling prophecies, the experimenter's expectations and consequent treatment of the subjects may influence the subject's behavior. To get around observer bias, we can use blind techniques, a way of controlling experimenter expectancy. The experimenter knows the hypothesis, but does not know which treatment condition the subject is in. Automate the procedures, a method to record and analyze responses by mechanical or electrical devices. Strict experimental protocols, reduce experimenter bias. Frequent checks, determine if the protocol is being followed by the experimenter. To control for experimenter attributes, different experiments with different attributes can be used in a given study. The more free of bias an experiment is, the more valid the measurements made by the experimenter. The validity of the measurement. Check the experimenter's reliability. Inter-experiment reliability. Use two and check between each other. Intra-experimental reliability. Check the consistency within one experimenter. Intra means within, inter means between. The appropriateness of measurements. To accomplish a specific purpose of a study, assuming that the instruments are reliable and valid measurements of the variables of interest, has the researcher selected the most suitable kinds of measurements from among the various options available? Were the measurements chosen for what the researcher wanted to look at appropriate? Appropriateness of the instruments from subject studies. Tests standardized on adults would be ill-suited for children. A test developed on children from one socioeconomic group may not be valid when administered to children from a different socioeconomic level. Data analysis. Typically, the last portion of the methods section describes how the data will be organized, summarized, and assessed. How the data will be analyzed depends on the research question from the introduction and the research design outlined in the methods.